Hi, everyone. So first of all, I want to thank the organizers for putting together this great conference and for letting me speak here. I'm really happy to be back in Amsterdam. So today I want to talk to you about building modern web applications with GraphQL, Hasura, and Vue.js. First, a little bit about me. I'm a developer experience engineer at Hasura. When I submitted this talk, I wasn't working at Hasura yet, so I started at the 1st of July, and I'm responsible for documentation, GitHub issues, and the whole developer experience. In my free time, I'm a community organizer in Zurich, so I love to bring people together and share knowledge and organize networking events as well. On weekends, I'm a mechanic for my boyfriend, who is a dirt bike rider. And it's a really nice balance to all the head work that I'm doing, because I read the 450 pages manual for his bike. So now I know how to repair stuff and doing all the manual work. And a few weeks ago, I tried it myself. So I will buy a dirt bike in November and as a backup career for my programming stuff. OK. So let's talk a little bit about the agenda of today. So who of you is already using GraphQL? OK, quite some people. So I will give an introduction to GraphQL for those who have not heard about it or don't know what it is. Then I will show you how to build APIs, GraphQL APIs with Hasura. Then I want to show you how you can connect your GraphQL backend with a Vue.js frontend. And finally, I want to show you some new features that will launch soon at Hasura. So first about GraphQL. So GraphQL is a typed query language, and typed here is really important because compared to other query languages, you have the type security so that less errors can happen when you insert something in the database. Then you have only one endpoint compared to other architectures like REST, and we will have a comparison of GraphQL and REST in one of the later slides. You can have nested resources. So for example, if you have a user and the user has a profile, you can get information from the user and from the profile in one query. You don't have to make one query, one request, and then get the ID and make another request for nested resources. The developer workflow is made a lot easier between front-end and back-end developers because of this one endpoint. So if a front-end developer needs a new resource, they don't have to go to the back-end developer for them to create a new endpoint, but it's just available because it's only one endpoint. And you get exact results. For example, if you have a user and you only need the email address of the user and not everything else, you just get the email address, so it's a lot easier to have an overview of your data. This is an example from the GraphQL website. So this is how you define a type project, and then you have all the fields, and as you can see, you have to state the types for each field. Then let's say we make a query, and we say here, we query the table project, and we want the project that has the name GraphQL, and we only want the tagline, not everything else. And then this is the result that you get, exactly the precise information that you were looking for. Now let's compare REST and GraphQL, as GraphQL is slowly replacing REST in a lot of big and also small companies. So some big companies that move to GraphQL are Facebook, of course, Twitter, and GitHub. A lot of them are moving. So for REST, you have an endpoint for every resource. So, and they're also different depending on which database action you want to perform. And if you have nested resources, there's a lot of chaining, and it can get difficult to have an overview. Then with REST, you have all the different HTTP methods like get, post, delete, and update. And the potential of overfetching and underfetching is pretty big because usually you get too much information while you only need one thing, or you don't get everything and have to make another request to the API. With GraphQL, you have one endpoint. It's always a post request, so you don't need to worry about the different HTTP methods. And you only get the data that you actually need. So let's have a look at the REST example. So I learned GraphQL with the Star Wars API. and I don't like Star Wars that much. So when I knew how to do it, I implemented my Harry Potter API, which is open source. So if you want to learn GraphQL with Harry Potter, you can. Thank you. And so this is an example for REST. So let's say we have a page with all the Harry Potter movies. The endpoint is /movies. So far, it's not that complicated. But then we want to list all the characters of one movie. Then it's /movies, /the ID of the movie, /characters. And now we want to list the actors of the characters of the movie. And you see where this is going. This is the chaining that makes REST APIs quite complex sometimes. Now, you can build your own GraphQL server without a problem and write your own API. Or you can write something like Hasura. You can use something like Hasura to create your API. And I want to give you a quick introduction about what Hasura is. So it's a real-time GraphQL API. Real-time means that if you connect it to the front end and the data gets updated, you don't have to reload or make a request. It just gets updated in real time. It's open source, so you can check out everything on GitHub. It's running on Postgres. This is maybe a little bit interesting. So you have a GraphQL query, and then it gets translated to SQL, run against the Postgres database, and then returned as a JSON to the client directly. Hasura is currently the fastest GraphQL engine on the internet, and the reason is that it's implemented with Haskell, the functional programming language, maybe you know. So yes, so this is the basic overview of what it is, then what we want to have. So the goal is to have low latency. So when we make a query, we don't want to wait for the data to come back. We want to have instant feedback. Then we want to have high throughput. As I mentioned, when we have nested resources, there can be a lot of nested data that we want to return, and it has to be fast. And it should be light on resources. It shouldn't use a lot of CPU and memory. Now, some of the features, so authentication you do as you already do before. You can use all the different types of authentication you can think of, like JWT authentication. You can integrate Firebase authentication or webhooks, whatever you want, you can connect it to your API. Then authorization is part of Hasura itself. So there's row and column-based access control for each of the tables, and I will show this later in the demo, how it looks. Hasura is running in the cloud, so you can deploy it to any cloud that is running Docker, because Hasura is always running in a Docker container, so you can deploy it to Google Cloud and anywhere where you can deploy Docker. You can, if there's concern about data security, for example, some of our bigger companies cannot have customer data in the cloud. So what they do, they just have a Docker instance running locally on their servers. And if you have business logic, for example, an email service or a payment service, you can use serverless functions and then add triggers on your tables that get executed when some database event is happening. For example, if I want to subscribe to new Harry Potter movies, and then when one is inserted, serverless function gets triggered that sends emails to the subscribed people. OK, so let's see how this works. So we have here the landing page, and here you can see all the cloud services where you can deploy Hasura. So we're using Heroku. It's the easiest to try that. So let's Harry Potter API, ITNEXT. Deploy the app. This takes like 10 seconds. And in the meantime, we see what actually is deployed. So this is the Heroku template that is deployed. And in the app.json, we can see here in the add-ons that the Postgres add-on is added automatically. You don't need to care about any of this. And also, if you don't specify anything else, the free tier of Heroku is deployed, and there's no need to pay for anything. By the way, Hasura is free to use, and you never pay anything to Hasura. If you have at some point 1 million users in your application, you might pay to the cloud provider for the traffic, but you never pay anything to Hasura. So now this worked. So we can view the app. And if you view the app, you get to GraphQL, which is a GraphQL interface that helps you handle your API. So here, what we can see is this is the one endpoint that you have to configure once in your front end, and from then on, you don't need to care about making requests. It's always a post request, and it's always to this endpoint. So then this is the place where you make queries, and here you get the results. But before we can make queries, we have to insert some data. So let's make a table movies. A table always needs to have an ID. We say UUID, and then we generate it randomly. Movie has a title, and here you can see we have to state the type of each field, and also has a release date, which is of type date. Then we have to specify a primary key, which is ID, and then we can add the table. So because this was so much fun, we create another table called Scenes, also has an ID, and has a name, and takes how many times we need to get the scene right. It's an integer. And primary key is again ID. OK. So now we have two tables you can see here. And now let's insert some data so that we can make queries later. And maybe another one. And then let's make two scenes. Set opening. Oh, forgot. And closing. OK. So now what we can do is we can make queries. We can say, from movies, we want to have the title. And then the two movies will show up. If we also want the ID, for example, you can specify whatever you need from these tables. And similarly, we could make a query for scenes, but you can see here now that we created two tables, and usually scenes belong to movies. So at the moment, the data is completely decoupled. So we want to make relationships now. So we go to the scenes table, and we add a movie ID, because it's an array relationship. So one movie has many scenes. So we need to add the movie ID to the scenes table. It's a UUID. And it's by default nullable because we already have two scenes that don't have a movie ID, so we cannot make it mandatory. And then we can create a foreign key. And we can say, now we're in the table scenes. We say movies, and oh, I have to create this first, because otherwise it can't show up here. Now it's movie ID. And inside the movie table, it's the ID. So we save. By the way, all this I'm showing, you can also do through the CLI. With the API, you don't need to do this in the UI if you prefer to do it on the CLI. OK, so now we have the relation. We added the foreign keys. And now we can go to the movies table and to relationship. And now it suggests us this array relationship that we can add. And we call it, like it suggested, scenes. OK. So now we have the relationship. And now we want to actually add the scenes to the movies that we created before. So we need, let's say, both these scenes. We're in Harry Potter 1. So we can edit this. And yes, and the other one as well. So now you can see here the movie ID. And here as well. OK. So now both these scenes belong to the one movie. And now when we make a query, remember we called the relationship scenes, so now we can call this like it's a normal field, and we can have the nested resources. And what did we name it? Name, yes, I think. So we get the movies with their scenes array in the query. What you can also do is subscriptions. So this is used when you want to have real-time updates for your web applications. So the only thing we need to do is replace query with subscription. So then we can run this, and now you can see there's a stop button. So this is now we're subscribed to the table, basically to both tables. And what we do now is we open this in a new tab, because we want to leave the subscription running. And now we add a new movie. And when we go back to the subscription, we can see that the movie was added without reloading. So this is when you subscribe to certain tables. OK, we can close this. So now we've seen how you can get data from your API, but sometimes, I mean, not sometimes, always, we want to write to the API. And this is done with mutations. And I cannot go into this in very much detail, but I just want to show you how a mutation works. So we name it, it's basically a function, so we just pass the parameters that we need. If it's an exclamation mark, it means we have to provide these fields so that we can create a movie. And then these insert actors, this is helper function that is provided by GraphQL. The same are there for update and delete. And then we just assign the input variables to the actual field in the table. And with GraphQL mutations, we always have to return something. So in this case, we return everything. And because this is a dynamic function where we pass variables, we need to actually pass these query variables, because we said here they are mandatory. And then we can run this. And now I think the app went to sleep before the talk. So we wait for a while, and then you can see what we ask to return, and then it's inserted in the table. With Hasura, you can have remote schemas. I will show a demo a little bit later. So what you can do is stitch different schemas together. For example, you have another GraphQL service. You can just add this and then make queries from one central point to all your APIs. This allows teams to work independently, but still at the same time, you can access the data from one point. This is the business logic I was talking about. So you can have event triggers that trigger serverless functions. And again, you can use all the cloud providers for these serverless functions. I think that is everything for this demo. Oh, no, I wanted to show the permissions as well. OK. So we have here, all the tables have permissions, and here you can define several roles. So you have an admin. By default, you're just an admin, and you can do everything. But then, for example, for my Harry Potter API, I also have a user role. And users cannot insert, update, and delete my movies, but they can select, so they can make queries. And then I can add here permissions, and I say custom check. And if I have users that are logged in or not logged in, then I can just say here, the ID needs to equal X Hasura user ID, and this is then passed in the header of the request. And I can also say the user should be able to edit or to manipulate only type, title, and date, but not the ID. So I can also have restrictions here. Yes, so let's go back to the presentation. OK. So this was a quick overview of how you can build your API. Of course, there's a lot more to it, but I only have half an hour. And now I want to show you how you can connect your API to a Vue.js frontend. And now we go to demo again. So very quickly, so you have to import maybe if you're using already GraphQL, you're probably familiar with Apollo Client. So Apollo Client helps to make requests, GraphQL queries and mutations to your GraphQL API from any JavaScript framework. So here we create an HTTP link, this is the one time you have to define the endpoint that you then will write to all the time in all the components. And we create a new Apollo client, we pass the HTTP link, and we have an in-memory cache. We will see just in a minute what we use this for. And yes, we create an Apollo provider as well in combination with Vue. Then we have here 3 components. The one is the movie item. And to see how this looks, I will show you the page first. So we have here a form, and here a list of all the movies. And one item on the list is this movie item. Then we have a movie list, and this is where it gets more interesting. So we need to import GraphQL. And here what you can see, this query is the exact same query that I'm using in the Hasura console. So I can just try this out in the console and then copy paste it to my front end. And yes, here we have to call Apollo and say we want to make this query get movies that we define here. And this is not interesting. So now the form. So again, we need GraphQL and we need the in-memory cache here. So this is again the same mutation as we wrote before. And here we call Apollo mutate, and we call the mutation that we defined and return all these 4 fields from the new movie. And now here we need the in-memory cache. So what we are doing here is when we make a query to get the movies, we store it in the cache. And then if we make a mutation, this new movie will just be pushed to the array in the cache and then shown on the front end, so we don't have to reload. This is another way of doing this. You can also do it with subscription. Then you don't need to worry about cache, because then the WebSockets basically subscribes and updates automatically. I just wanted to show these 2 ways of doing this. And now let's see if this is working. So let's insert actually a Spider-Man movie. I am the director and the composer. And it will come out soon. So I send, and now we can see here without reloading that the new movie was inserted. So this is how you can connect this to your front end. OK, so now I want to introduce you to some new features that we'll be launching actually in the next few days. One of them is remote joins. So I showed to you that you can already stitch schemas together. But now we introduced a new feature that you can actually join tables across different APIs. So the situation is that in a lot of modern IT projects, there are a lot of third-party services that you use, for example, payment services. Sometimes there are multiple databases and microservices. And the source of truth is spread across all these different microservices, databases, and third-party services. So now we want to be able to join data across all these data resources. So the idea is to have a centralized access point. As I said before, you can access all the data from one point. You get precise slices of data. You also don't have to make several requests to the API. And the security is secured in the same way as I've shown before with the permissions. And there's also an allow list that you can create where you can say only these and these queries are safe to be used for the API. Use cases, why would we need this? So one example is if I have 2 different databases, so APIs. One is the authors DB and the articles DB. But of course, I want to be able to get the authors with their corresponding articles. And I prefer to have this in the same query. So this is how it would look. So we have a query for authors. And the ID and the name, this is in our current API. And when we create relationships across schemas, then I can also use it, as I've shown before, just as a relationship with articles and get the fields from these remote schemas in one query. One other example is a lot of APIs are using Auth0 for authentication. And same here, I might store in my API only the ID and maybe the name of a user, but I also want to have all the information from Auth0. A third example is Stripe, the payment service, and I will show an example of this here. So this is where we add remote schemas, and we said we would use Stripe. And we can use OneGraph. So OneGraph is a service that allows us to integrate different GraphQL APIs with each other. So here you can see we added, so this is the URL from our Stripe service. And once we added this, we can create relationships. And here we have the customer. And under relationship, we can see that the customer has a relationship to the Stripe service. And what we can then do is we can make a query. And we use the email and the name are from our own API that we store. And then we can call the relationship Stripe and get all the information from Stripe here in one query and can then use this for whatever we needed. So this is one of the features. And the other one is called actions. So we've seen before how mutations work. We insert something into the API, into the database. But now there will be the possibility that instead of just inserting something directly, you can call serverless functions inside the mutation that get triggered, one or more, and then the whole result gets back to the API. And you can decide if you want to do this whole circle and then get the result, or if you want to subscribe and get updates after each serverless function that you create. And one example would be, for example, a food ordering app. So you place an order, then the order needs to be approved, which is a serverless function. Then the order needs to get assigned, and the restaurant needs to approve. All these kinds of steps are different serverless functions, and you can then decide, do you want to do the whole procedure of the order and then get back the order and insert it as a mutation in your database, or do you want to get live updates, which is what you usually want to do for a food ordering app to inform the client, hey, your order has been approved and the food is on the way to you now. So this is something that we'll be launching soon as well. Now, very quickly about the community. So we have Learn tutorials on learn.hasura.io, where you can make tutorials. For example, there's a backend tutorial where you learn how to build an API a little bit more in detail than I was able to do now. And for all the frameworks, there's separate tutorials. Then if you have questions, there's Hasura Discord server where the community is quite active, so you can ask questions, and then either the team or the community will answer your questions. And new features will be announced on Twitter. That's it from myself. I want to say thank you, and also I have some T-shirts and stickers if you're interested, and otherwise I will be around. You can approach me anytime to ask questions and to talk about GraphQL or anything else. Thank you so much.